Check, check. Check, check. All right. We're about to get started with some more Solana programming. Man, I'm having fun with this. I got I'm gonna plug my personal Twitter. Want to follow along? I'm getting a lot of good information off Twitter, so I'm asking questions and hearing people respond. So that's going well. So yeah, follow me. You want to follow Grom's Club, twitter.com/Grom's Club here. And you want to follow me, twitter.com/Adam Del Sol. And most importantly, you want to mint a Grom, and then you want to join the Discord, the Grom's Discord, where we're learning this stuff together. All right. But yeah, so we have our rush streams; those are still going strong. Don't worry. You know, I had this is kind of a holiday week, so I wanted to spend time doing stuff that I really enjoy. I enjoy Rust, but digging into Solana programming, I understand that it's really exciting right now. So I hope you're enjoying it, and I hope you're learning with me. I'm not expert at any of this stuff, so I may get the details wrong, but please correct me if I get something wrong that you're aware of, so we can talk about it. I'm just making sure we got our stuff set up here. We're good. We got our on-screen drawing because we do it big and fancy here. Just making sure that's working. Excuse me. Yeah, so we're still working through paulx's perennial introduction to programming Solana. It came out it's a little shy of a year ago. Maybe that would be cool. I don't know if we could get there with time, but that would be really cool if we finished. We did the last stream on this the same day. That would be something. I don't know if it'll work out that way, but if it does, cool. Depending on how our momentum goes, maybe we'll shoot for that. So we really did a lot of talking during our setup here. I was talking out loud to kind of get some of this information really in my head. We learned about state and accounts and how those, work in Solana programming. And then, the kind of big thing we started learning here was the system program. Let me turn off Discord. We don't need that bugging us. And how the system program owns our Solana accounts. So I'm gonna kind of talk about accounts some more and the relationship with programs, because this is going to be really key to understanding Solana programming. Let me just actually, I'll bring up a tweet that I had that I actually drew out. There it is, this one. So we're going to dig into this in this next section, but I just kind of want to give a, some level setting here with all this. So on the Solana blockchain, you have this system program that's kind of like almost like a master program, I guess you could say. Let me get this down here. too thick. Okay. We have our system program. I don't know why I'm trying to be so careful with my writing. We know it's not going to be good, right? But it's good enough, right? So we have our system program, and then we have like my Solana account, right? We're just going to call this a account. And by Solana account, I mean really my wallet. And part of that is I never have this drawing down. I struggle with this drawing pad and like any mini writing apparatus, mini writing apparatus, because I'm a lefty. Jeez. I'm actually like hitting these buttons sometimes, like with my hand. Pub key, which is just the public key, right? We know what that is. You know, that's like what we give out so people can send us coins or whatever. And private key, right? And our private key is used to sign transactions. It's kind of like how we, you know, how we interact with the balance of our, or like how we can debit our account. And that's the only way to debit our account. So there's this relationship here where we have this account, and your account, in a way, doesn't actually own your Solana account. You have a separate account for your like your SOL token, your SOL token. Okay. And the system program actually owns that account. And so you don't actually own this account, even though you're able to debit. You know, you have sovereignty. We can say you have ownership in a way of this account, and that you can use your private key to send Solana from this token account to other people's token accounts. And so the system program has this associated, and it's actually it's a property in the metadata of the token account, if I remember correctly. That I'm not going to write this out because it's just going to be messy. But the idea is that this SOL token account is has metadata that includes the identifier for my account, that lets the system program know that I can sign for this Solana, this allocation of Solana to be debited. Okay. So there's a system program, and then there's another program like this, like the Solana, like the system program. In some ways, that's called the token program, and kind of the standard program that I think the majority of tokens that are not the SOL token, the Solana token, use this SPL token program. And SPL stands for Solana Program Library, I believe. Let me get out of that mode for just a second so we can look that up. Yeah, Solana Program Library. Let me get this a little bigger so we can read it. The Solana Program Library is a collection of on-chain programs targeting the. Okay, so that's not really telling us what token program, right? So token program is a big one, right? So like, let's get our drawing apparatus back up here. So when I have some grape token, or let's say when the grape token was created, it was created using this SPL token program. And what was created was a mint. Let me make that a little bigger. Grape mint. And then from that, we can now create, and I'm going to put an A here so you know that this is mine. Whenever I was sent grape originally, the this token account was created for me for grape. So this is like my A's grape account. All right. And then similarly, in the way that the system program owns my Solana token account, and this is account to be clear. Sorry guys, my handwriting's never been good. It's even worse on this, but I'll get better. Similarly, in the way that the system program owns this my Solana token account, the SPL token program owns my grape token account. And they talk about, and Paul talks about this in his introduction. We'll get to that. Now I can sign for both my Solana token account and my grape token account using the same private key, right? So if I one way to do this is, if you're designing a blockchain, would be to my wallet, instead of just being like one public key and one private key, I'd have my Solana token public key and private key. I'd have my grape token public key and private key. But now it's just like kind of becomes a big mess, right? Because it's like I have to have a public key and private key for every single different token I have. I don't know if specifically that's why it was designed this way, but that's at least one advantage of why we have, instead of like from one account, my one account owns all my token accounts. I actually am associated with these token accounts via these on-chain programs. So just to be clear, this system program is on the Solana blockchain, and this SPL token program is on the Solana blockchain. So somebody wrote these programs. The system program, from my understanding, is one of these ones that has special privileges. I believe this SPL token program does not necessarily have special privileges. So theoretically, you could write and deploy your own version or your own instantiation of the SPL token program. You would just probably miss out on all the composability of the existing ecosystem that uses the SPL token program. I think. I don't know for sure, but it's important to kind of understand this going forward. And this was a stumbling block for me, and I only now began to understand it as I started doing these streams and talking to people with my questions. So I hope that's helpful. I hope this makes sense. If it doesn't, feel free to ask questions. Either the GROM's Discord is the best place to do that, to talk to me. So, yeah. But really, like, if you don't understand this, please do ask questions, because I want to make this as clear as possible. Okay, so let's get out of this for now. Let's go back to our tutorial. So we'll just run. This is from the last section we already completed last stream. Each program is processed by its BPF loader and has an entry point whose structure depends on which BPF loader is used. So that's getting programs onto the blockchain. We use the BPF loader. The accounts are used to store state, remember, because our programs only hold logic, they don't hold state. Accounts are owned by programs. That's what we were just illustrating with our drawing, right? That all these different accounts we have for the different tokens um, are owned by programs, not by accounts, other accounts. Only the account owner may debit an account and adjust its data. And so in that diagram that I drew, if we want to call it that, um, you know, my account was the owner of those token accounts. All accounts to be written to or read must be passed into the entry point. So that's more specific to actually writing the code. All right, so now we're in instruction.rs part 1, general code, the beginning of the escrow program flow. So let's bring our code editor back up. I'm gonna create, this is all an entry point. Yeah, okay, so we just started. All right, so we're gonna create a new file here in Visual Studio Code. We're gonna call it instruction.rs. And it says to register it inside lib.rs. So that's just giving it this module declaration, or whatever we want to call it here, in our lib.rs, which is the kind of the root file of our program. So this is just a file tree of what we'll see in our program. Give me just a second here. I'm gonna clear my throat. Yeah, so this is like, you don't have to, there's nothing that enforces this file structure. I think like when we first started seeing Solana programs on GitHub, they were frequently like one big file. And I don't know if that was just because, I don't know why that was. But now this is kind of common. But again, it's not like a strict standard that your program will be rejected somehow. It just makes the code more easy to read and modular. So we'll talk through these files as I create them. Lib.rs we already have. It's like, since this is the way this, like in a Rust sense, the way this application is structured, it's as a library rather than a binary. So instead of having a main.rs when we got started, we have this lib.rs. Entry point.rs is the entry point to the program. All we did was copy a lot of this code. We copied almost all this code from the lib.rs file of this original template that we're using. Instruction.rs is the program API, deserializing instruction data. So what this means is, this is like the interface to the program. This like determines what the interface is going to be when the program's on chain. Let me just add a file for this. Oh no, we already have that. Okay. And it deserializes. I think if you're not familiar with the term, I would recommend looking it up. But you can think of deserialize as just like taking data and like pulling it apart or parsing it into like the important pieces that you need to use. Processor.rs is the program logic. So this is like the actual logic that'll be on chain for us. Program objects, deserializing state. Yeah, so this is like a good example of this is like, remember we talked about needing a number of different accounts for this program to work. That's where this will be sent to, like, once it comes in, to the logic in our entry point, and at some point it'll need to pull that that state apart to see like what state the current like program workflow is in, or if there's any specific information that needs program specific errors. And this is just like we'll want to, whenever we have an on-chain program, obviously people that are not necessarily you will be using these programs, so you'll want to have good errors that are specific to what's going on if there's a problem, like if somebody didn't like send in a bad piece of data or something, you can tell them, hopefully like you should be good about sending back like what exactly they did wrong so they can fix it. Git ignore, that's GitHub or Git stuff. We're not gonna worry about that. Cargo lock, this is all our our boilerplate or whatever you want to call it, cargo Rust files. We're not going to worry about. I mean, we may add to the cargo toml file. Yeah, so here's a good flow of program. Someone calls the entry point. The entry point, let's just go back to these. Actually, let me create these. Sorry. Let me create these files real quick. We have entry point, instruction, processor. Let me go ahead and register everything while we're here before I forget. On state. And error. I like to do things in alphabetical order generally, unless there's like some other. Yeah. Entry point, error, instruction, lib, processor. Okay. So yeah, so using these as abstractions for our like what these different pieces of the program will do, we'll kind of use this as a as our abstraction for what these different pieces of the program do. So someone calls the entry point. So just remember that this is referring to the program once it's deployed on the blockchain. There's an entry point for the program, and this just means when a call to this program comes in, we use that entry point. The entry point forwards the arguments to the processor. So there, yeah, maybe I shouldn't have this because I think that just kind of confuses things. But let's just say this is sitting, this these lines here are abstractions for different pieces of our program. That's all sitting on the blockchain. Someone calls the entry point, so they call it this way, and they've passed in some data, right? Like whatever accounts are involved in this escrow transaction. The processor asks, or the entry point forwards the arguments to the processor. So like all the data or state that may be included goes to the processor. The processor says sends the instruction data. This would be like in our escrow program. Okay, so let's set up our escrow scenario again. I'm not going to use NFTs since this is going to be more like kind of standard fungible token, but they're relatively the same. So let's just do A for me, D for Deebs. And I don't know if this is a good trade, but I have 5 grape, and Deebs has say Deebs has 5 jet tokens. Okay, so I want to so I want to set up an escrow that when I want to trade my 5 grape tokens for 5 jet tokens from Deebs. So I'm going to use the escrow program that's on chain here. And I'm going to tell, with this entry point, I'm going to pass in the information. What are the important pieces of information, right? It's that Deebs has 5 jet tokens and I have 5 grape tokens. I'm going to send my 5 grape tokens to the program, and the program is supposed to send my 5 grape tokens to Deebs once he has sent 5 jet tokens to the program. And then the program should also send those 5 jet tokens to me. So that's all information that I'm calling with this entry point to initialize this escrow transaction, I guess, set of transactions. Okay. So the entry point is going to take that. The entry point will forward the arguments to the processor. That's really all the information that I said. And then the processor starts to what do we say for the all right, let me just say processor is the program logic. Okay. So the processor asks the instruction. So part of all that information I said was the instruction data. The important instruction data was like send 5 jet to Adam, send 5 grapes to Deebs once both have sent in their tokens, respective tokens. So that goes to the instruction .rs portion of our program, and then it decodes that, right? And excuse me. And then with the decoded data, the processor will now decide which processing function to use to process their request. Okay, this processor may use state to encode state into a decode, or decode the state of an account, which has been passed in the entry point. So this is where the processor says, okay, we got all this instruction data, and we understand what was passed in. Now I know at what our escrow program has multiple steps, right? And I'm just gonna scribble a couple here. This won't be comprehensive. I initiate. Let's just say A initiates escrow, and so I don't actually do anything at this point. I'm just basically telling the escrow program what I want to do. A sends. I mean, that theoretically these 2 steps will probably be happen in the same transaction, but let's just for understanding these steps, we'll put it so. A sends 5 grape to program escrow program, right? Just to be specific. And then the next step is that Deeb sends 5 jet to escrow program, right? So those are all different, these are all kind of different states that the escrow program could be in as part of this transaction set of transactions is concerned. All right. So using the code data, the processor will now decide which processing function to. So depending on what state these steps are in, or what step we're on, that will determine which processing function likely to use to process this request, the specific request, right? The processor may use state.rs to encode state into or decode a state of an account which has been passed the entry point. As you can see, instruction.rs defines the API or program. Okay, so let's get rid of this. Continue reading. While there is only one entry point, program execution can follow different paths depending on the given instruction data that is coded inside instruction.rs. So that just means depending on what information is sent to the program as part of the instruction data, different things can happen, right? It may throw an error. That's a different path that would happen, right? If something in our flow that we just illustrated earlier, uh, maybe like I didn't I didn't send the full account address or whatever, we'd throw an error back. Let me get a drink of water. Give me just a second. All right. So beginning of the escrow program flow. Happy New Year, Master Dojan. Good to see you, and thank you. I'm glad. I'm glad to have you here. That's very nice of you to say. That's my dedication is what we need to do things that are worthwhile. So uh, let's all be dedicated, right? Thanks, man. Cheers. All right. Let's now look at the different execution paths of our program may take by zooming out and sketching the program flow for escrow. So I think it might be. Oh yeah, we got these drawings here. I'll probably use these drawings to help supplement. I'll draw on top of them essentially. Alice and Bob, which means there are two system program accounts because Alice and Bob want to transfer tokens. Will make use of it. Guessed it. The token program. Okay. The token program told a token you need a token account. Both Alice and Bob need an account for each token, so we get 4 more accounts. I'll call our tokens X and token Y. That was one thing that I wish Paul had done here, is given these names more distinction, because when you're first going through this, it's kind of X and Y kind of get easily interchangeable in your head. Yeah, so our tokens are X and Y, but this escrow will work for any tokens on Solana like USDC and Serum. Since escrow creation and the trade won't happen inside a single transaction, it's probably a good idea to have another account to save some escrow data. It will store how much of token Y Alice wants in exchange for her token X, but we'll get to that later. Yeah, so this account here doesn't actually have any tokens. It's just going to store some of the state we need. Like, again, how much token Y Alice wants in exchange for her token X. This account is created for each exchange. Okay. I'm going to zoom this out a little bit so we can try to get more information. Hope that's still readable. So yeah, so this is kind of the state. One thing we just need to keep in mind that tripped me up here when I was reading through this was that this is the program after it's already been deployed, right? So everything we're kind of illustrating are different states of the program after our escrow program has been deployed on the blockchain. And so I'm just trying to scroll while keeping my drawing device active. And so this is like where it gets tricky, right? We talked about our system program. What happened? Yeah, so we have our system program that owns the accounts in our, you can think of these as our wallet accounts that have our own public keys and private keys. And then there's a token program that owns our token accounts, like we talked about. So just to be thorough and keep all this in our head, there's essentially three there's 3 different programs at play. So actually, I'll see if I can like keep an inventory up here. So there's 3 programs. I'm trying to find a good place. I guess we can do it over here. If I could write legibly, that would be good. 3 programs. And then, so that's the escrow program. This is the token program. And then there's the system program. Okay. So escrow program's up here. So I just can't scroll up and have everything on screen at once. But these programs are all on chain, right? And additionally, we have 6 accounts involved. Now, I'm not going to list them all out here because we can see them. And I'll talk about why we need them. So there's your main account, right? These are our main accounts with our public keys and private keys for Alice and Bob. Alice, because of this, like Alice, I forgot what. I think Alice wants X. What does Alice want? Okay, so Alice has X. Currently, she has, Alice, she already has X. She wants, let's do this, wants. So she already has a certain amount of the token X. That's horrible to read. And so if this trade is going to work, that means that Bob needs to have some amount of Y and wants some amount of X. And hopefully the same amounts, right? And that all has to be determined in the escrow program. So, for this escrow to work, we need to have accounts for each user. Alice and Bob needs to have an account for each token, even though they don't have, again, we're presuming the fact that both of these that this escrow transaction set of transactions will go through. So at some point, both Alice and Bob need to have a token account for X and a token account for Y. Okay, so that gives us 6 accounts. Their main accounts, right, which is their public key and private key that they use to sign for any token accounts associated with them, and then these X and Y token accounts that are owned by the token program but are associated with their main accounts. Okay, and what does that mean again? It means that with their main account, they can sign for debiting X and Y. Token accounts X and token account Y. Both of them can. So 3 programs, 6 accounts. All right. Let's try to keep those numbers in our head. Let's fade this out and get out of draw mode and read some more. Now, there are 2 questions you might ask yourself. How will Alice and Bob transfer ownership of X and Y to the escrow, respectively? And how are their main accounts connected to their token accounts? To find the answer to the questions, we must briefly jump to the token program. And this is already kind of what we talked about when I drew, I think when kind of close to when we first got started. The naive way, so this is one reason, right? If Alice owned main token account, she would require to keep a private key for each token account. It would be much easier for Alice if she just had one private key for all of her token accounts. This is exactly how the token program does it. Note that this So this is like some kind of behind the scenes information that is actually a little confusing, and I was asking about it on Twitter just a couple hours before the stream. So this token account owner attribute is not the same as the account owner. The account owner is an internal Solana attribute that will always be a program. The new token owner attribute is something the token program declares in user space. So this term user space can be a little confusing. This is like, I think one thing, maybe we don't say it enough, is that these blockchains are really operating systems, right? They're operating systems that run across multiple computers. And because of that, there's actually baked into their architecture, especially smart contract platforms like Solana and Ethereum, are these idea of like user space and system space. These are operating system concepts that I don't know. I don't know if you necessarily, I certainly don't have a great grasp on them, and I don't know if you necessarily need to be a Solana programmer. It probably helps in the long run, and I think over time, like I'm assuming I'll understand it better. But so what it's saying here is like there's two times that this account owner is mentioned, and they mean different things in different contexts. So there's an account owner in that. Sorry, let me bring my. There's the account owner in that a program is the account owner, right? And then there's this other like account token owner attribute that happens in user space and is actually defined in the program. It's encoded inside a token account's data in addition to other properties. So I think for the most part, we're going to be able to like just like if we really internalize this idea that the token program owns all token accounts, like we can just like set that aside and not worry about it, right? And then know that when we're talking back up here, when we're talking about the owner, right? Like we're talking about the owner, like what we mean is Alice, right? Alice, while she doesn't technically own these accounts, right? She does in that Alice can sign for these accounts to be debited, but technically, only programs can own token accounts. Okay. So a new token, such as in addition to other properties of balance tokens account, the account holds. What this also means is that once a token account has been set up, its private key is useless. So all those accounts we have, like Alice's token X, they actually have public keys and private keys, but the private key itself is useless because only the token owner can is allowed to sign to debit the token account via the token program. And the other token owner attribute is going to be some of that address, in our case, Alice's and Bob's main account, respectively. When making a token transfer, they simply have to sign the transaction with the private key of their main account. Okay. This is like, again, like this stuff is pretty heady. So if it's not clicking right now the first time you're watching the stream or this video, definitely like read this again, like read this multiple times, and if necessary, watch this video multiple times. And more than anything, come to GROM's Discord and ask questions so we can like learn together. All internal Solana internal account information are saved into fields in the account, but never into the data field, which is meant solely for user space information. So this is just like kind of again sequestering of context, really. Yeah, so this is just saying that a token account is modifiable by the owner program. You can modify the LAN ports, which is a certain amount of Solana token and the data, and this is not modifiable by those programs. The key is signer attribute that is writable, owner, executable, APOC, which I don't know if it's important for us to go into those things right now. You can see all this when looking at a token account in the Explorer. It parses the account's data properly and displays its users fields formatted properly. Let's get out of our drawing program. So here's a token account. It's a mint, which I think we talk about. I think we talk about in a moment what this mint is, but this is actually a token account. Excuse me, for USDT, right? This token account is empty. There's no token holdings. I'm not sure what domains means. Maybe that's like, I think that's like Bonafide domain naming service or something. This is the address. So if you want to send USDT to this account, you could use this address. Owner. So this should be so this is the main account, right? This is like, if we look at this, actually this might give us that. So let's say this was a USDT token account. This is the USDT token account, or token account X. And if I'm understanding correctly, this is the account of the owner, Alice's system account, or main account, as it's referred to earlier here. So ideally that would be consistent. So I guess it's like, okay, yeah. So he changes these fields. Probably notice the mint field and Explorer. This is how we know which token the token account belongs to. So this is just like, saying that, hey, this is a USDT token account, and the mint is like this is where all the USDT flows. Basically, it's minted by this Tether, the Tether organization or whoever they're called. I forgot their names. And yeah, so you'll see that for NFTs, right? And that's where you'll see like the actual NFT with a mint, because there's a mint. The NFT is just like one token. A NFT mint is just that one token. It's not like necessarily a mint for like a set of tokens, a set of NFTs. This is how we know which token the token account belongs to. For each token, there is one mint account that holds the token's metadata, such as the supply. For each token, there is one mint account that holds, which is the supply. We'll need this field later to verify that the token accounts Alice and Bob usually belong to asset X and Y. So that's like, we need to make sure, like if X is USDT, we need to make sure that when I send, when Bob sends his token, he's sending USDT and not USDB or whatever, and we use that by verifying the mint ID. I think it's called an ID. Mint authority. Yeah. And this doesn't have to be like USDT, the symbol. This is like a whole other, this could just be like an address of some kind, I guess. I'm not sure what that actually looks like, but this is using the SPL repo that registers these symbols. For each token, there's 1 minute that account that holds in metadata. For the online populate our world with more information. Okay, Oh, so this is good. I like this this terminology here. Instead of owned, like, so owned is owned by the user, right? The user's wallet, and it belongs to the mint. And I guess we've kind of done away from with the token program. Oh, okay. So owned by token. Yeah. So the token program ownership is illustrated using the green, and the account ownership, if we associated, is so I just this terminology is like it's kind of frustrating. So I just want to look at the. So I was actually tweeting about this, and I saw some different associated token account. So I think that's a pretty good one. So Munib here, DevPsycho0, is saying that all token accounts are owned by the token program. So the owner generally means a user owner. So I guess what he's saying is, like, when you talk about this, they just say that when you say the user, it's like you take for granted that the token program owns the account. So whenever you say owner, you just, we can agree we're referring to the actual user owner and not the token program. Yeah, for simplicity's sake, I've removed the program, the arrows will be colored the other accounts appropriately. Now we know how all those accounts connected. We don't know yet how Alice can transfer tokens to the escrow. We'll cover this now. The only way to own units of a token is to own a token account that holds some token balance of the token referenced by the account's mint property. Hence, the escrow program will need to account to hold Alice's X tokens. Okay, so all this is saying is, like, just like Alice and Bob will need a token account for each token type, X and Y. The escrow program will also need its own token accounts for X and Y. Okay. One way of achieving this is to have Alice create a temporary X token account to which she transfers X tokens she wants to trade. The token program sets no limit on how many tokens for the same mint one may be the owner of. So this is actually, like, something to be aware of, I think, because you may see this. The program can have multiple accounts of token X, right? That's all it's saying. And there used to be, I feel like early on in Solana, like, I would end up with like multiple USDC balances in my wallet, and that was because through interacting with different programs that were, I think everyone was still kind of learning the ropes. They were creating new token accounts on my on my wallet, associated with my wallet, instead of just adding to the balance of my existing token account. Now, it's possible that problem still exists, and Phantom just, like, abstracts all that away so we don't worry about it. But I honestly don't know. Then, using a function in the token program, she transfers token program ownership of the temporary X token account to the escrow program. Let's add the token program. Let's add the temporary account to our escrow world. This image shows escrow world. So this is like the state. When you're saying world, another way to think about that is state. The state of the escrow world, or the state of the escrow set of transactions or workflow before Alice transfers token account ownership. So Alice has created another. So Alice already has her token account here. Whoops, I accidentally created an arrow. Okay, somehow I'm making arrows now. You'll have to ignore that. Oh yeah, let me just. So Alice already has her token account here. Alice creates another one so that she can associate to this escrow program. Okay. So there is a problem here. What does Alice transfer ownership to? Because she's not actually. This is this is not like a. She wants to transfer to the program, right? Not like the um, not like another person. So what does she transfer ownership to if it's the program? So enter program derived addresses. So this is another concept. I think we're yeah. Let me see how much more we have here. All right. Um, we're going to talk about program derived addresses, and then we're going to call it a day, because I'm actually going to pick this back up next Solana stream. So before we do that, let's go over our theory recap. Developers should use the data field to save data inside accounts. Okay. I don't really know that we went over that so much, but that's fine. The token program owns token accounts, which inside their data field hold. I guess this is the way we went over it, right? We talked about the token program and how it owns accounts. The token program owns token accounts, which inside their data field hold relevant information, like who is the user space owner, the user owner, the associated token owner, I guess. The token program also owns token mint accounts with relevant data. Yeah, so that's like the USDT account. That's a mint account. The token program allows user space owner of a token account to transfer its ownership to another address. So one way for me to transfer grape to Deebs would be for me to let's just say I just wanted to give Deebs 5 grape. Let's say I have 10 grape and I'll give Deebs 5. I could create a token account with and put 5 grape in there and just give ownership of that grape token account with a balance of 5 to Deebs. All internal Solana and internal account information are saved into fields in the account, but never into the data field, which is solely meant for user space information. All right. We're going to dig into this stuff more later, so I'm not going to go through this. Plus, Rust. These documentation is tricky to read through until you get used to it. All right. So we're going to start talking about PDAs. I don't know, and we're probably not going to finish today. We like program derived addresses, and this is something I'm still getting my head around, and it's commonly what you will. It's a thing that people like take a little while to figure out. So if this doesn't make sense at first pass through, don't worry. We'd like some way for the program to own the X tokens while escrow is open and waiting for Bob's transaction. The question is then, can programs be given user space ownership of a token account? Can a program be made an owner of a token account? That's the question. Well, no, but actually, yes. The trick is to assign token account ownership to a program-derived address of the escrow program. For now, it is enough for you to know. For now, it is enough for you to know this address exists, and we can let a program sign transactions or assign user space ownership of accounts. We will cover PDAs in depth later, but for now, let's go back to coding. So this is like a really high level talk about it, and I guess we'll learn more about it later. But let's go ahead and just draw this out a little bit over here, I think. So there's the let's just call it our escrow program is here, right? Oops, we've deployed it. Let's say we're at some unnamed step of our escrow workflow. And so here's my main account or system account, right? And I need this escrow program to hold on to my grape before I get to Deebs, right? So I have I am the user space owner of this grape account. And I have 10 grape. Okay. Well, I want to send 5. I want the escrow program to hold on 5 grape. So when Deebs sends me his 5 jet, the escrow program will send the 5 grape to Deebs. Sorry. I want to send 5 grape to the escrow program so that when Deebs sends 5 jet to the escrow program, it will send 5 grape to Deebs. But it's an escrow program, right? It's not an account. So instead of just sending grape to that program, what I actually do is create a program derived address to which I send to which I send 5 grape, excuse me. And then, so this has been, I'm down to 5 grape here in this account. So right now I have 2. That's a mess. So now I have, so now I have 2 accounts with 5 grape each. And I've created, with this new account that I've created using this program derived address, which we'll go into later, I actually just assign ownership of this account to this program. So I say that I'm assuming it's a token program, right? Our token program that owns these token accounts in the system space. I say, hey, the escrow program is now becoming the user space owner of this grape PDA account that has 5 grape in it. Okay. So that's my understanding of it. And I think it's a high level understanding of what a PDA, like what we're doing here. And we'll go deeper later on. Excuse me. All right, so let's keep trucking a little bit. I want to write this code out and talk at least through this part. What else? Yeah, so we're just going to go through the accounts involved and set up our escrow instruction, No, we're not going to go to this. All right, here's what we do. We're going to get through this, the very beginning of this instruction, RS part 2. We're going to talk through these accounts. And I'm actually just going to copy all this because y'all don't need to see me. Ugh. You don't need to see me type this all out. So, yeah, we're not even going to read it over here. We'll read it over here. Okay, so let's remember what an instruction.rs, it's our API endpoint, right? And so what that means is when there's a client, in most cases, it's like a website, right? But it could be like a mobile app or a server or anything. It's going to interact with our, I want to draw this out because this is important to understand. So here's our escrow program, right? Here's our escrow program. And there's a number of ways to interact with that, right? There's like a website, um, whatever. There's a website that's on a computer. There's a mobile phone. We're gonna have an old school mobile phone with a home button, a touch screen, right? And so these, and with that screen, there's an app, right? There's a app, I guess. Just right, app. Um, and so these are all clients, potential clients of our on-chain smart contract or Solana program, right? Same thing. And our escrow program sitting up here on the Solana blockchain is just hanging out. It's not going to do anything unless anybody calls it. Theoretically, you could, yeah. For this purpose, for what we're doing, our escrow program will not do anything unless unless we call it from a client. Okay. And so client is like a abstraction for any device or application that is interfacing with our on-chain program. And so how does it interface with our on-chain program? It's by using this API endpoint, the API of the program. What does API stand for? Just to be explicit, application program. I'm actually not even sure this is right, but it's close enough. Application program interface. Okay. And so APIs are everywhere. They're all over the place, within your computer, outside your computer, on servers, across the internet. APIs are everywhere. So your escrow program that has all sorts of information, or excuse me, logic and information stored off in state accounts and all that stuff, it has an API. And all that is a way for these clients to interact with each other, with the clients to interact with our on-chain program or application. Application and program are synonymous in general. They mean the same thing. I guess that's why it says application and program in this acronym. Um, and so that, like, if this escrow program is just running on the blockchain and a client can't interact with it, it's all it can do. There's no way to like write to it and get anything out of it. You can maybe it displays information. You can read information by observing its output somehow, but the API just makes a very distinct language for any client, whether it's a website or a mobile app or a desktop app, to interface with this program. Okay, and so like when you hear about front ends, you think of like, what does a website look like? Like this blog has, behind my drawing has a scroll bar and text and all this stuff and these links up here. That's the front end of this website, but the text, the information is probably stored on a server somewhere, maybe not, but in general, that's the way web works. But oh man, oh yeah. So I actually sometimes refer to like these API endpoints as the front end of the program. I'm not going to do that when we talk about this, because that would just make it more confusing, I think. But this API endpoint that 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 articulates how to interact with the program is like a front end. But it's more than anything, it's an interface. And so that means like this escrow program is going to need certain kinds of information, right, for it to work. It's going to need the accounts. It's going to need the amounts of tokens that are going to be expected, and some other information, right? And so how that information is sent to our program from a client, be it a website or application or whatever, is the interface. Yeah. And yeah, I think that makes it clear. Excuse me. So this escrow instruction. Let me get rid of this. And this escrow instruction is the API. With this knowledge, we left off with the knowledge that this file would define the API of the program. Without having written any code yet, let's start coding by adding init escrow and init escrow. All right. So this is an instruction that will be on a program that other applications can interface with. This specific instruction that we're defining here is the init instruction or initialization instruction. And so what that means is, in our situation where I want to create an escrow transaction set with Deebs, either I or Deebs could initiate the escrow. The outcome's the same if our escrow program is written properly, but it needs to be done by one of us, right? And so this is the interface for that specific step of our transaction or our escrow set of transactions. And so it's here. It says start the trade by creating and populating an escrow account and transferring ownership of the given temp token account to the PDA. So remember, we need to create a temp. Alice needs to create a temp token account for X, and they're transferring that to the PDA. And here's all the accounts that are expected as part of this initialization step or function, I guess you can call it. Instruction. Yeah. Initialization instruction. The signer, the account of the person initializing the escrow. So this would be Alice or me in that case. In the case of Adam and Deebs, in the case of Alice and Bob, it's Alice. The temporary token account that should be created prior to the instruction owned by the initializer. So I'm creating a temporary token account for Grape because I want to send Grape to John after this is done, or Deebs, excuse me, or Bob. I'm getting all these names confused. The initializer's token account. We have this note that it's writable because it's owned by Adam Del Sol or Alice. The initializer's token account for what they will receive should the trade go through. So if I'm getting Jet from Deebs, I need to supply my token account where the Jet will be sent to, and the escrow account that will hold. And so this is like our data account. Remember, our program doesn't hold state or data, so this is the account for that. And then rent sysvar and the token program, which, yeah, the token program, we know we've talked about this in length. And the rent sysvar, this is a new thing that we'll get to next time. Okay. I think that's a good stopping point. It's actually not the best stopping point. I'm running out of time here, and I'm not going to get as far as I would like to get. So what I'll do is I'll pick this back up and review this portion when we start our next Solana stream, which will be sometime next week, likely, maybe this weekend. Thanks for hanging out, Master Dojin. If you're still here, thanks for chilling with me. Have a happy New Year's. Go mint to GROM. Join the GROM community. We're going to start providing. Some of this is going to, like, these streams are always going to be free, but we're going to start providing, I think, some more goods to our GROM holders. So you're going to want to mint a GROM at paddleout.groms.club. Happy New Year's, and let's keep programming on Solana. All right, later.